Your physics students will climb to new heights after investigating leaning ladders with Pasco's new wireless two-axis force platform. The leaning ladder problem is a staple in the study of static equilibrium. However, few students get to investigate it by directly measuring the forces. In this activity, we use a dynamics track as a stand-in for the ladder. By placing it on the wireless two-axis force platform and leaning it against a wall, we can directly measure the vertical normal force and the horizontal static friction force. Our wall in this case is a tripod, not the best choice, but a classroom wall, the door frame, hallway, any smooth surface works really great. So let's see, I have a digit display here. The normal force is on top and the parallel or static friction force is on the bottom. So 17.7 and almost 4 there. Students can then predict what will happen to these two forces for different lean angles and immediately see the results. So let's move it out and away. So 17.7, 3.9. And one thing I was pretty sure was going to happen, but maybe not that other thing. What's going on here, your students will want to know too. After measuring the weight of the track, students can use the two conditions of static equilibrium to predict the normal and frictional forces for a different angle. A Pasco track angle indicator makes it easy to measure the track's lean angle. It also makes it easy to hang a weight at various locations on the track. Students can predict how moving the weight further up will change the normal force and friction forces. So we got 27 and 7.3. So it's kind of like the guy climbing up the ladder. Does that change things? If so, how? Interesting. In the ladder problem, the force of friction from the wall is usually considered negligible. Students can test this assumption with measurements from the wireless two-axis force platform. Students discover that the friction force from the wall is the difference between the weight and the normal force. They find out that the wall friction force increases as the lean angle decreases. Here you can see that the normal force is less than the 18 Newton weight of the track. So about 1.5 Newtons or so less. They use this knowledge to predict the lean angle using the normal and parallel force measurements and the weight of the track. The leaning ladder investigation and a teacher guide with sample data can be found in the Pasco experiment library. An investigation of a vertical jump and a bouncing ball can also be found there. Look for more wireless force platform videos on our website, pasco.com. Thanks for watching.